This video is the result of a collaborative effort between MSU and Purdue Extension's work with unmanned aerial vehicles, or drones, to see how useful aerial video would be at detecting anomalies in a center pivot irrigation system. Imagine being a repairman sent to weld a patch on a leaky center pivot span in the middle of the winter. Think how helpful a video of the water application and the leaks would be in helping you to determine where the repair is needed. Even the off-season task of changing out faulty sprinklers can be greatly reduced if you have video of the sprinkler application patterns from last summer to guide you to the location. Being able to see the pivot from a fixed point like this could be useful, but oftentimes you need to see the water move to pick out differences, and the view from the ground is not as advantageous as from above. Capturing video of the pivot in operation is invaluable, not only for seeing trouble spots, but also for being able to reference them at a later date. Determining the best altitude and position to fly and the best angle to video is a matter of trial and error and will depend on factors such as quality of the camera, crop, stage of growth, time of day, and degree of cloud cover. Positioning the drone parallel with the pivot can make it difficult to see the water throw pattern, especially against the sky. The speed of the drone needs to be slow enough to be able to see details and not give you a headache, especially when looking straight down. Flying parallel to the pivot from a greater altitude is an improvement, but you can still only see a small section at a time, sort of like looking out your side car window while driving down the highway. Flying directly above the pivot can be helpful in seeing anomalies, but it can be difficult to steer the drone when looking straight down, as you will see here. It is also hard to make adjustments in altitude as ground contour changes, and you do not want to fly your drone into the water spray. Flying at a higher altitude here, about 30 feet above the pivot, helps you to see more of the pivot at a time. Then, when you see something interesting, you can drop down for a closer look. Note here the obvious throw difference due to worn caps on these Nelson 3000 sprinklers. We found that flying above and to the side of the pivot while aiming about 45 degrees to the direction of travel allowed us to easily operate the UAV and see what we needed to see on the pivot. Hopefully you found this video useful in seeing the value that a UAV can have in identifying and recording problem areas on a center pivot irrigation system.